Good morning. My name is Vishnuvardhan. I am from B.Tech Triple first year. My roll number is 21951 capital A 0246. My topic is solving solutions to matrix and applications in control. Let's see introduction. Information in science and mathematics is often organized into rows and columns to form rectangular arrays called matrices. Matrices are often tables or numerical data that arise from physical observation, but they also occur in various mathematical contexts. Linear algebra is subject of crucial importance to mathematician and user of mathematician. When mathematician is used to solve a problem, it often becomes necessary to find a solution to a so-called system of linear equation. Application of linear algebra are found in subjects as drivers as economic, physics, sociology and management consultants use linear algebra to express ideas, solve problems and model real activities. The aim of writing this subject is to applying matrices to solve some types of system of linear equations. So let's see different types of matrices. Matrix. An Mn matrix A is rectangular array of m into n numbers arranged in m rows and n columns. The ijth component of A denoted Aij is the number appearing in the ith row and jth column of A. We will sometime write matrix as A equal to Aij. An Mn matrix is said to have the size Mn, and we can see examples too. So second method, square matrix. The matrix which its number of rows equal to number of columns is called square matrix. That is A is equal to A11, A22, AN1, A21, A22, A21, like that AM1, AM2 and AMN. When m equal to n, then A is a square matrix. Unit matrix. The n and n matrix Ln is equal to Aij defined by Aij equal to 1 if I equal to j and Aij is not equal to 0 if I is not equal to j is called the n identity matrix. That is I2 is equal to 1 0 0 1. It is simply the diagonal elements are 1 and non-diagonal elements are 0. Null matrix. A zero matrix is a matrix which its elements are zeros and is denoted by the symbol 0. Properties of zero matrix. A plus 0 is equal to 0 plus A is equal to A. A minus A is equal to 0. 0 minus A is equal to minus A. 0 into A equal to 0. A into 0 equal to 0. Diagonal matrix. Diagonal matrix is a square matrix in which all the elements not on the main diagonals are 0. The elements of square matrix A where the subscripts are equal, namely A11, A22 form the main diagonal. Commutative matrix. We say that the matrix A and B are commutative under the operation product if A and B are square matrix and AB equal to BA, and we say that A and B are invertibly commutative if A and B are square matrix and AB is equal to BA. Example, A is equal to 5 1 1 5, B is equal to 2 4 4 2. A into B is equal to 14 22 22 14. BA is equal to 14 22 22 14. If AB is equal to BA, then it is called as commutative matrix. 6 1. Triangular matrix. A square matrix A is n into n is triangular matrix if Aij equal to 0 when I is greater than or equal to j plus 1 or j is greater than or equal to I plus 1. There are two types of triangular matrix: upper triangular matrix, lower triangular matrix. A square matrix is called an upper triangular matrix if all the elements below the main diagonals are 0. Lower triangular matrix. A square matrix is called lower triangular matrix if all the elements above the main diagonals are 0. Transpose of matrix. Transpose of Mn matrix A denoted by A transpose or lambda is n into M matrix which Aij is whole transpose is equal to Aij. Properties of transpose. Let A and B be matrix and C be a scalar. Assume that the size of the matrix are such that the operations can be performed. A plus B whole transpose is equal to A transpose plus B transpose. C into A whole transpose is equal to C into A transpose. AB transpose is equal to B transpose A transpose. A transpose whole transpose is equal to A. And seventh one, symmetric matrix. A real matrix A is called symmetric matrix if A transpose is equal to N. In other words, A is square n into n and Aij is equal to Aji for all 1 is less than or equal to I less than or equal to n, and 1 is less than or equal to j less than or equal to n. Skew symmetric matrix. A real matrix A is called skew symmetric matrix if A transpose is equal to minus A. In other words, A is square n into n and Aji is equal to minus Aij for all 1 is less than or equal to I less than or equal to n, or 1 less than or equal to j less than or equal to n. Determinant of matrix. The determinant of the matrix A is equal to Aij is a number denoted by A modulus of A or det A, through which important properties such as singularity can be briefly chapterized. This number is defined as the following function of the matrix elements, where the column indices j1, j2, jn are taken from the set 1, 2, so on n with no repetitions allowed. The plus sign is taken if the permutation is even. Singular and non-singular matrix. A matrix is said to be singular if det of A is equal to 0. A is non-singular if det of A is not equal to 0. There is some theorem, so it is just for an example. Orthogonal matrix. We should say that the matrix A is orthogonal if A into A transpose is equal to A into A transpose is equal to I is equal to A transpose into A. It is known as orthogonal. 11th one, Toeplitz matrix. A matrix A is said to be a Toeplitz if it has common element on their diagonals, that is Aij equal to Ai plus 1 into j plus 1. Nipolent matrix. A square matrix A is said to be nipolent if there is a positive integer p such that A of p is equal to 0. The integer p is called the degree of Napoleon of the matrix. Periodic matrix. A periodic matrix is said to be a periodic that period k if A is satisfied A k plus 1 is equal to A, and if k is equal to 1 then A square is equal to A. So A is called in idempotent matrix. 14th one, squatic matrix. An n into n matrix A is called squatic if each element is a number between 1 and 0 and each column of A adds up to 0. This is known as squatic matrix. Trace of matrix. Let A be a square matrix. The trace of A is denoted by trace of A is a sum of diagonal elements of A. Thus, if A is an n into n matrix. Properties of trace. Let A and B be the matrix and C be a scalar. Assume that the size of the matrix are such that the operations can be performed. Trans of A plus B is equal to trans A plus trans B. Trans of AB is equal to trans of BA. Trans of C constant into A is equal to constant into trans of A. Trans of A transpose is equal to trans of A. Hermitian matrix. A square matrix is said to be a Hermitian matrix if A transpose is equal to A. Note the conjugate of a complex number Z is equal to AIB is defined and written Z is equal to AIB. So this is the solution to the matrix and its application in control. Thank you.